All right, let's get started today. Um, One thing I want to remind people of is the course feedback form here, um, and complete that. Um, it's a good chance for you to make suggestions on how to tweak the course. Um, I'm thinking that one of the things you might want to look at is the way Thursdays are set up with discussions. I don't know what, so right now we only have three students in the classroom and it's 10:04 there. So those of you who aren't here, I would like to know, have you explain why maybe or what you'd like to tweak on this to get this to work here. Um, so yeah, are the is the discussion something you dislike? Would you like to avoid that? Are you more like, do you like to, you know, complete the worksheet? Do you want to just get rid of the worksheet? Do you want to do the worksheet um, asynchronously? I'd like to know some information about that for this there. So make sure you fill out the form and do that. I'm certainly going to make at least one, if not more, changes to this course after I see the results of this form. So this form will have an impact on this course and how we have things set up for it. So, um, so let's just walk through this a little bit. We want to have a little bit of discussion here, and I'm going to continue that today, even though there's not many here, but actually we'll see how that works. So let's talk a little bit about the discussions there, and then there's the worksheet here, and we'll have you work on that for this stuff. So, um, let's talk a little bit about a discussion. I'm going to put up this discussion topics, which is just some of the discussions. I actually have seen quite a bit of pretty good discussion in Brightspace. So it seems like we're having some good discussion there. So that's good to see for this. So um, I'm going to put this up and go sit down, move the camera around here and see how this goes. Jeffrey. Going down to some of the, I guess I'd say maybe meat potatoes of parsing and stuff like that. And scanning and looking at how that actually can work. Um, there are a couple good general questions about is there anywhere, any real world job where you'd actually find this stuff useful? To tell you the truth, this is, we will get, one of the things of this course is this will hopefully make you better programmers because you understand how the program works underneath somewhat and how memory management works and stuff like that. So the argument generally for this course is that it can help you know how programs work better by understanding it below the surface there. To tell you the truth, this is the first year I've taught this course at this school, and I've been teaching here for 30 years. So for 30 years, we've said this course is not that useful to students. that there are other courses that are more useful. It's always a hard thing to choose, what to teach, here, how to teach this. This is actually supposed to be two courses, a lot of universities, a programming language course, that computational theory course. Again, if you are doing computer science and you are going on to grad school or something like that, then this sort of theory stuff and just the whole idea, it's kind of like calculus. Calculus underlies so much stuff in math, that that if you don't know what derivatives and integrals are, how they work together, there's so much of math you just and physics and stuff you can't really it's hard to understand clearly. Similar here, I guess you don't understand some of Turing machines, push down automata, context-free grammars. There's a lot of computational theory and computational stuff, research, into designing new languages and that sort of stuff, which aren't that useful. I mean, that are hard to get at here. So, there were some questions about optimizing that sort of stuff, and do you see much like compilers being slow, or I guess, yeah, what do you think about optimization and this sort of stuff? Do you think you wait a lot for compilers to go, or to building takes, does that take long, or are you thinking about optimizing somewhere different?
I don't think it takes too long in my experience usually.
When do you think the build happens? Because one thing I'm seeing nowadays is a lot of the environments are doing constant building in the background. And so, because it used to be you program for a while, then you'd have to hit a compile button, and then it would scan, parse, and compile your program and build it there. But now I think most IDEs are always building in the background as you make changes, so that when you're ready, when you want to run, do you see that? I mean, you don't have to hit a build button much anymore, or compile button. You just hit a run button, right? So I think that's one thing that's sped this up, where a lot of the compiling is being done in the background as you do things. The other optimization that we'll actually get to a little later is just optimizing your code. The compilers have some flexibility in how they generate machine language here, and so there's actually a lot of work done to make the code that's generated, the executable faster with the same stuff. And you really don't see that much. I mean, it used to be we have some there are different Java IDEs out there. You can use NetBeans, or you could use IntelliJ or whatever. But when you compare them, you really no longer talk about how fast of an executable they generate, because they all kind of do the same sort of optimization. That's kind of all kind of set now, I think, for Java, where it used to be more likely that you choose an IDE because it would generate faster machine language code, faster executable, so it would be doing better optimization. Okay, let's talk determinism a little bit. People were asking what are some of the advantages of being ambiguous syntax? When do you want to use non-determinism and that sort of stuff? And in my mind, it's something you kind of want to, it's just like in English, generally you want to avoid it there when possible, because it's often harder or possible to write a parser with that is ambiguous or is non-deterministic there. So you generally want you want determinism here because you want to be able to parse things up. The problem is well, let's say
Well, there's a couple possibilities, right? You can, well, when you write a program, you ever wonder, like, when you use AI, I type in a prompt, I sometimes wonder, what is the AI going to tell me? Because I don't know there. But when you write a program, do you ever wonder how the computer is going to interpret your commands? Like, is it going to take it this way or is it going to take it that way because it's ambiguous? So. The common one we'll look at today is the hanging else. If you say like, if X is less than 10, and then within that you say, and then your statement is if Y is greater than 20, do this else, and the else could apply to either of the ifs when you have a nested if there. And so that can be ambiguous, but every programming language now defines how to make that unambiguous there, so that if you write it that way, you should there is every compiler has to figure out how it's going to interpret that stuff. So again, one of the things we sometimes do is we make things ambiguous initially when we're designing them just to go because it's easier. But then there's a process of taking like for every non-deterministic like context-free grammar, there's a process we can use to turn it into a deterministic grammar also. So, you do some scanning in base. I can't remember what's in the worksheet, what's in the assignment here. I think in the assignment we actually have you generate code for a Lexer and talk about that. For scanning, so what questions you have about scanning and like turning a code into tokens? Do you have any general questions on that? Yeah, that's the thing that came out, like how does it know when it, like if you have a missing semicolon, how does it know that there for that, and what does it do for that stuff? So and again, I don't the Excel that we do don't really get into that too much, but one thing you will do is we will try to parse like an expression with an error in it, and we'll try to figure out. So when you try to parse an expression with an error, at some point you won't be able to apply any rules to it. None of the production rules will fit the input there, and then so that's when you need, you'll generate an error, and the question is then what do you generate as the error, and how do you interpret that error there? I mean, so one thing you can do is you kind of look at, well, what if you have these set of production rules, if you have these tokens, you can replace it with this token. And if you have these tokens, you can replace it with this token, stuff like that. What is the closest rule that fits there? And find the one that fits, if none of them fit exactly, what's the one that fits it the closest? And what is missing from that? And that's some, you can sometimes use that logic to suggest where the error is, and that like you're missing a semicolon here, or you're missing something like that here. Now people were asking about AI in parsing and and scanners. That's something I just haven't really thought much about, is how AI is going to be used with this. this, because right now it's really not used much in the IDEs. As far as the compiling, where do you see AI being used? So if in your editor, it might suggest corrections there, but it's not being used in the actual compiling much, or even the error generating. I don't think, like telling you that they're missing semicolon. We're still. So how are we doing? Is anyone using like Copilot or whatever? Like, I know in Colab Gemini runs in there to look at the Python and will tell you, if there's an error, you can explain this error and it will pop up and tell you what the error is and suggest a likely solution there. And from what I understand, I haven't used Copilot here, but my understanding is it kind of does the same thing in the IDE. So, yeah, what are your thoughts about AI and this?
It's really useful. I never used it like in an IDE, but one of my coworkers did, and like I think it was like the GitHub Copilot.
Yeah,
and like it would just be suggesting blocks of code based on the context of what he was writing, which is pretty cool.
right. And we've had some of that, like simple fill in the rest of the line or the rest of the statement, like you type in something dot, it'll list out the possibilities there. But again, now we're getting where we're having it generate whole sections of code and stuff like that. So I think that would be very useful. So, who else has used it, or how have you used AI with code? We were just having a conversation about these programming contests that we have, and right now you can't use AI, or like generally like a programming contest, you can, like one of them, like a lot of the ACM ones, you can just bring printed material out there and stuff like that. But it's getting to the point now where like my Python IDE has Gemini built into it, so I can't even tell students not to use Gemini because again, it's right there in the environment. So it'll be interesting to see, if at some point for these programming contests or anywhere we program, if that'll be the assumption is that you'll have AI available to you, and what will that mean for like a programming contest or something like that. Let's talk. A number of people were asking questions about Python's indenting versus Java's braces here. So I think it's in the worksheet today. So Java has a generic brace, right? For an if, you use a brace. For a while, you use a brace. Any sort of block has the same start brace, end brace. Have you ever programmed in a language that has brace or begin block, end blocks that are particular to the structure? For example, there are a number of programming languages where you start an if statement, you write if, and then you write all your statements in there, and the end of the if is if spelled backwards, phi. So you start the if statement with if, and at the end, instead of using a brace, you write phi there. And again, with a loop like while, you start with while, and at the end you write while backwards. And like there's not a switch statement, it's a case statement in this language I'm thinking of. So you start case and you list your different cases. And at the end of the case statement, you write ESAC, case backwards. So there's a bunch of more reserved words because every reserved word has generally the reserved word backwards as the end of that section. So have you ever seen a programming language like that?
Yes, Python.
Does Python use it?
Or maybe it was Python. It was like you just say like if, and then you don't have to like have it.
Okay, so Python you say if and then you just do indents, but you don't put a phi at the end of it.
Yeah.
Right. So again, the older way, again, I think was that, I think that's a pretty old way of doing this sort of structure where you'd have it. Cause then it's much easier to match where this end matches up with this, you know, when you're trying to match up braces, there, so. But, so that's one way, and then Java has the brace and then brace the two blocks. And Python just has indents, there. So what do you think? How do you think they manage the indents? What would that, how would that add to this complexity?
I thought there was a way of recognizing the number of spaces because you can use when you're programming, you can if you're gonna use spaces, I think it's like 4 spaces for a tab,
Yeah,
and then if you don't put the exact number of spaces, it's not it's gonna be a wrong code. It's not gonna give you the same results as if you get the right number.
right, yeah,
So I thought maybe it counts the number of spaces, but then that made me think like, so what about all the other spaces that you're gonna have in the program in your
Right,
code? Is that
yes.
affect?
right, yeah. Right. And again, what we're often doing is the scanner is going through and reading each character and trying to generate tokens from that. And the tokens are what's important. But we usually just skip over all the spaces, what we call white space, right? Tab spaces, things like that. We just skip over those. We don't process those. But in Python, we've got to process those
Exactly.
there. And what you'll see, and we'll see this today, I think, is that what a Python Lexer or Python scanner will do, it'll read those spaces and it'll generate a token called indent. There it is. So like if your first line's indented 4, then from then on, every time it sees 4 spaces, the first 4 spaces, it'll call that an indent. And then if it sees some more spaces, it'll generate another indent and another indent. And then it also has something called a dedent. If it sees that missing, and it is kind of hard sometimes, and I'm not quite sure. We'll have to look. I think we'll explore a little bit today on that indent and dedent and how that is when you're reading the language, how that is generated for that. But then once that's all done in the scanner, so then once you get to a parser, it's not that much different than Java because Java, you'll have a start, a start block and an end block, or a brace and an end brace here. And then as far as tokens go, and in Python, you just have an indent and a dedent as the tokens there. So you'll see that. Well, why don't we get started on this worksheet? Because I think it's kind of long. Okay. Let's see. Simba's online. Simba. Okay. So remember that, again, I mentioned earlier, course feedback. If you don't want to do this discussion anymore, put that in the course feedback. If you want to do discussion somewhere else, do that. If you want to do something. One thing to remember is, think about the other courses. What courses do you've been taking courses. You've been aware that you've been taking courses for at least 12 years now, right? So you've seen a lot of different teaching styles. What do you think would work well in this course, with this course material? And suggest that. And what do you want to get rid of? Really bothers you, put that in here. Okay, let's do worksheet stuff. This poll activity. We're gonna pair you up again.
Worksheet stuff you'd like to do. To help me understand, please tell me.
Thank you, Gemini. You're very helpful today. Was that Gemini or was that OpenAI? My phone talks to me. Yeah, so, okay. Yeah. So we'll do a couple groups here and we'll get this started. So we'll do randomness again. So, and just to remind you, next week we're going to be, oh, I'm going to be out of town, here. So, we're not going to meet in class next week. No synchronous meetings, here. We'll have, well, everything will be basically the same. I'll record a couple videos. We'll have the same sort of assignments. We'll have QQTP discussions, but we will not just have that. We'll just have them in Brightspace. There will be a worksheet. You have the choice. You can complete the worksheet individually or in self-selecting pairs. So if you want to come next Thursday in this classroom and work with a partner or just work with a partner anyway, you can. If you want to do it individually, you can too. So you can decide how you want to do it next week. Okay. So why don't you get together? We have pairs. Simba, I don't have you're the odd person today, so I'm gonna let you work by yourself on this stuff. So let's see. So yeah, why don't you get together in your pairs? Where'd we end up with people?
Oh, yeah.
So just a quick note here, some of these questions I think are complicated and we haven't covered, so feel free to use AI. I assume you're comfortable doing that anyway, but again, I don't, you, when you're working on these together, or on this sort of stuff, certainly feel free to ask AI and stuff like that. But when possible with your responses, I'd like to make sure you understand the responses that you're pasting in there or whatever. So I don't want you just to like take every question and just post it to AI and then post the response in there. I want you to read through the response, and often AI will give some wrong, complicated response, and I just want you to condense it into something you understand, you and your partner, or can get to. So feel free to use AI, but use it well, I guess, as a learning tool for this. Make sense? Yep. Yes.
What do you mean by the state transition?
Yeah, let's talk about that. Let me kick this up. So a table, a transition table or a diagram should try to convey the same thing. And what you're trying to show, right, is that like here, we start at state 0. And if we see this input, any letter, we say, oh, it's an identifier. So we go into that state 1. If we see a digit, we say it's going to be a number. We go into that digit area, that state 2 here. Now, when you're in, now you'll see the next thing. So if you're in state 2 here, so you've seen a digit, and now the next thing is a letter, then you're going to say, oh, that's the end of the number. We're going to accept that number and go on. If you see another digit, you're going to say, oh, that's still building this number, so that should go on. So like here, once you see one digit in a number, right? Can I get this editor? So once I see one digit and I see another digit here, so let's see if I can. If I see another digit here, let me see if I can end this here. Then I'll stay in that state, because that's what it's showing me here, is that if I'm in state 2 and I see another number, I stay in state 2. So you want to do an arrow like from state 2 back to state 2 whenever, again, you're seeing a number again. Then you'll stay in the same state. But if you're seeing anything else, if you're seeing digit, now you see something that's not a digit, it's no longer a number. So then you will accept this. And then generally when they accept means you go back to state 0 here. And there's different ways you can kind of denote that, whatever you want. Some people like to just add a state over here just called accept. It means we accepted the last input. And so if we see, like, if I see, let's just do an arrow here. If I go from here to the accept, certainly if I see some letters, I will go to the accept state for that. And then the accept state is kind of like the same thing. Once we've accepted a token, then we go back and start again. So that's why some people will draw this actually just going back to 0, because once we accept a token, then we start over again for that.
So is anything other than the block that it's in going to be accepted?
Right. And again, this is a pretty simple thing. So like on most, like here, once you see an equal sign, everything, there's no in this grammar, there's nothing that can come after an equal sign. We don't have an equal or equal less than available in this. So once we see an equal sign, the next thing is just an except here for this one. Okay. So yeah, and again, most of these will be this way where once you get you'll see an assignment and then you'll go to the except state or with any other character here. So for that. So however you want to draw that or visualize that, there's not a great standard way of doing it. Okay. Yes. Okay. So then some questions about the part 3 with the parsing, and just want to demonstrate what we want. So I actually think it's easier to skip 3.1 and do 3.2 first. And again, I don't know why there are 2 columns or 3 columns. There should only be probably 2 columns there. So you want to start with sentence, and then you want to apply one of these rules. There's only one rule, noun, verb here. So every row here, we're going to apply one rule and go on to the next one. So from sentence, we're going to replace sentence with noun, phrase, verb, phrase here. And now we have a choice. We could either replace noun phrase or verb phrase. I'm just going to randomly do verb phrase here. So I'm going to try verb phrase up here. Now, this is the rule. Now, this is actually 2 rules. Anytime you see an or, it's basically 2 rules. Verb phrase can be verb or and noun phrase, or verb phrase can be verb there. And I mean, we could have written this down as 2 different rules. I mean, we could just as well have written it down like this. And the or is kind of there just to apply some sort of shorthand. So this is another way of thinking of that, is the verb phrase is either verb or noun phrase, or verb phrase is a verb there. So I'm doing that rule, verb phrase is a verb. And then so where verb phrase is, I'm replacing it with verb. And then I'm using the word verb can be, again, chase, sees, or eats. And I'm choosing sees. Verb is a sign sees. So now my sentence is a noun phrase and then sees. And I keep doing that every time I apply one rule here. And I keep on, and eventually I just get to these final tokens, the dog sees, and that's my final sentence. Not a very exciting sentence, but so that's what I'm putting up here, the dog sees. And then there should be, this is one way of applying the rules. You should have choices sometimes which rule you want. Maybe right here, I wanted to apply a noun phrase at this point, and so, or at this point or something like that. Or I want to do the noun before my article. So there's different choices. So you can do the rules in a different order if you want and see how it works. And then again, the parse tree is just a visual version of the order in which you did this for this. Okay, see how that goes. Jump into one more thing on 3 when we're talking about these parse trees, because we really haven't talked about parse trees too much. And I'm going to try to do this on the board here. You can see that. So again, we have these rules and we're applying these rules one at a time. And I'm generating a sentence, the dog sees here. And I can do this, I can apply the rules in a different order and get the same, the dog sees. So this, like here I did one order, here I did the other order. But this isn't a very ambiguous grammar. So I think these will both generate the exact same parse trees. How do we do a parse tree? So again, I'm going to do a sentence up here. And I'm going to replace that with a noun phrase. And a verb phrase. So I did this rule. Now I'm going to replace it with the verb phrase. I'm going to replace with just a verb. And then the verb I'm going to replace with sees. And that's a terminal one. And then I'm going to go back and do noun phrase is going to be an article and a noun. And then what do I do next? I do the article becomes the. And then the next one is the noun becomes, what did I do? Dog. And then I get the dog sees here. Now, I can do this in a different order and I'll generate the same exact tree, I think. So if I go down and do it in this order here, again, I start with sentence. And then I have to do noun phrase and verb phrase. There. But now I'm going to do the noun phrase first. So it just basically dictates the order in which the tree is generated. So now I have a noun, an article and a noun. And a noun. And now I'm going to do, the noun is going to be dog right away. And then the article is going to be the. And then I'm going to do the verb is a phrase is just a verb. And then the verb just gets to be sees. But these two parse trees are identical. The framework of them, the way they branch is exactly, I may have created them in different orders, but the result, the parse is the same. So that's one thing that we like about parse trees is that no matter what order we apply the rules, you should generate the same parse tree. Now, there are times when the language is ambiguous, and then depending on what order you apply your rules, you'll get different parse trees here. And that's why, like, sometimes we'll say like the brown cat and dog jumped. And you don't know if it's a brown cat or a brown cat and dog there and stuff like that. So there's ways to set this up so that it's ambiguous and you can get two different parse trees. But with this limited example, I think I don't think there's any ambiguity here. So you have to see. I'd be interested to see if anyone, if you don't always generate the same parse tree for two things. Okay, does that make sense? Particularly for the online people. And again, if you haven't done or you've done it, you can just see. So for like 4.1, we have this sentence and we have it tokenized. So I'm going to grab up here, we have the tokenization of it. And so I'm just going to copy that down here because I think that's helpful to kind of see. And we're going to start by calling parse. I'm just going to have a list of the functions I call down here. And the first one's parse. I'm going to look up and see what parse does. Parse just calls expression, very useful function. So the next thing I'm going to do is just do, parse is going to call expression here. Oops. And then what does expression call? Expression calls term, and then it'll enter a loop. So the first thing it's going to call is just term here. And then term is going to call factor and then go into a loop. So it'll call factor here. And then factor is going to check if there's a left paren there for that. So factor is going to check. And the first thing is a number, not a left paren here. So it's not a left paren here. So it's just going to go down here and it's just going to be a number. So it's going to call consume here. And so it'll call consume and it's going to consume the 3. I'm going to actually just paste this whole thing. And so it is consumed this. I could delete it. Maybe I'll just cross it off. So we've consumed that now. for this stuff. And then that was in factor, and that ends factor. So now we go back to term. We've done this, and now we're going to enter this while loop. While token is times or divide, we are going to consume it and do another factor. So let's see. The next token is a plus. So it's not, again, we're down to, it's not a multiply or a divide here. So we're just going to return from that here. And again, maybe I should be indenting these, but I'm not. So, and then, yeah, so then we go back up here to expression, and expression, we keep looping. We look for a plus or a minus, and there's a plus. So we're going to do a consume and then another term here. So we're going to do a consume. And then we're going to do another term it's going to call. And so consume is going to consume the plus sign. So we'll read in the plus sign here. And then we do a term again. And up here where we get to term, it'll do a, oh, so we did a consume. We assume, wait, oh, another term. So yeah, so term can be, we'll do factor here. So we'll call factor. And again, your idea is just to keep walking through these calls, what's going to be called when and what consumes what. So factor. So again, it has done this 3 plus, and then it's going to see this multiplication here as a factor. So factor, we're the next thing is a number 5. So when we're doing a factor, if it's a left brand, it's not, it's a number. So then we're going to consume it, that number for this stuff. So then we're going to just going to consume that number. We're going to consume this number. And we've consumed that. And so we were in factor, and we consumed that number. So now we return back up to term here. So we did that first factor. Now we're going to see it, if we look for a multiplication and a divide, and if we find one, we're going to consume it and do another factor here. So again, and the next number is a times. So we can enter this while loop up here, here. So we'll do another consume and another factor, and we'll consume the times thing here. So again, do another consume and another factor. And again, if you want to note this in a different way, that's fine. This is just some way to keep track of where you are here. So we're going to consume that multiplication sign, and we're going to do another factor. And again, now we're going to, the next, we've consumed this multiplication. The next item is a paren. So that'll send us down a slightly different path. So again, that's what we want, is just how are these recursive or not, or these methods called to slowly consume, and they should consume all of these values here. Every time there should be an option. And then later on, you'll do an illegal expression. What you'll do is you'll start doing this, and at some point, you won't have a rule. Nothing will apply here. So try to walk through this and tell me, where do you get the first illegal expression where none of the rules apply? And what do you think the code kind of does? Okay.